In this video I'm going to talk to you about the symmetry of the unit circle. So first of all, let's just remind ourselves of the unit circle. The unit circle is called the unit circle because it's made up of a circle with radius 1. Now, if we're going to look at the coordinates in this unit circle for some particular angle, so what I mean by that is all the coordinates that go around the circle with a particular angle. So this angle theta, for example, you will have looked at boundary angles before. So here we've got pi over 2, here we've got pi, 3 pi upon 2, and of course 0. The unit circle, the beauty of the unit circle is it keeps going. So actually up here, although it's 0 degrees, it keeps going round. When we get to this point, it's now 2 pi as well, because we've gone round a full circle. The good thing about the unit circle is it can go in either direction. We can actually go below 0. We can look at angles below 0, and we can follow that in the clockwise direction. So if we were going in that particular direction, you'd have 0 minus pi upon 2 minus pi minus 3 pi upon 2, and it would continue to go round and round because the unit circle replicates the sine, cosine and tan curves, which you will study in a later video. So let's have a look at these coordinates. So of course, as the angle gets bigger and bigger and bigger, this point continually moves around the unit circle, and it's this coordinate that we're looking at in regards to whether we're looking at the sine ratio, the cos ratio, or the tan ratio. So let's have a look at each of these coordinates. We call this the first quadrant when we're looking at the Cartesian plane. In the first quadrant, all of the coordinates are positive. So we actually put an A in place, okay? If we look at the second quadrant, the coordinates, some of the coordinates are negative, some of them are positive. However, we call this quadrant 2. If we talk about the actual ratios, sine, cos and tan, only sine is positive in this quadrant. If we look at the third quadrant and we think about the values of sine, cos and tan, only tan is positive in this quadrant. And if we look at the fourth quadrant, only cos is positive in that quadrant. That means the coordinates still exist, but any other ratios apart from sine must be negative in this quadrant. Again, in this quadrant, all the others apart from tan are negative in this quadrant, and of course all except cos are negative in this quadrant. They're all positive in that quadrant, so that's easy. Now, so you've got to try and find a way of remembering it. So I usually call this a cast diagram. Some people call it all stations to Cleveland, because I guess all starts in quadrant 1, because this is the first quadrant. So all stations to Cleveland is a really good way of remembering this. So let's have a look at what happens as this moves round. Now, because of the unit circle being symmetrical, we can see the quadrants themselves are symmetrical. The radius is 1. It means that this is also our angle theta. And of course, if I was to draw another line down here that mirrors this one, the same size angle from there is symmetrical as well. Obviously, we're dealing with some positive and some negative coordinates here, but the angle itself is symmetrical. So what does this mean? Well, this means that if we can use our calculators to calculate the first acute angle, which is usually given in either quadrant 1, sometimes quadrant 4, but let's just focus on this quadrant. If we get the acute angle in this quadrant, it means that we can work out what other size angles are in any of the other 3 quadrants by looking at the symmetry properties. Looking at this, the size of theta, whatever it is, we can work out what this coordinate would be, or the value, depending if we're looking at sine, cos or tan, by subtracting it from pi. Pi subtract theta will work out the values in this quadrant. Because remember, the unit circle goes around this way, so these are all bigger, bigger, bigger. If we want to go backwards, we need to subtract. Again, if we want to know the size of this one, if we have theta, pi plus theta will give us this one. Similarly over here, we've got 2 pi at this point. 2 pi subtract theta will give us this value here. And of course, if we're working all the way around again and we go past 2 pi and we want to keep going up and round, 2 pi plus theta will be this one, and so on. And it works all the way round, and that is due to its symmetry properties. I'll clear some space over there and I'll do some examples with you. Alright, so if I know that sine of 30 degrees is actually 1/2. Now you might know that, or you might have seen my videos on exact values, or maybe you've just used a calculator to work it out. If we know that sine 30 is 1/2, Let's see if we can work out from the unit circle the other symmetrical angles that fit in that circle. So for example, here's 30 degrees. Here's our x-axis and our y-axis. We know cast all the way around, all stops to Cleveland. Now, let's have a look at what this angle over here would be. Well, this angle, if we're looking in degrees, you can do it in radians as well, this angle would be 180 minus 30. 180 minus 130, sorry, 180 minus 30 is 150 degrees. We can say that sine 150 is, well, because sine is positive in this quadrant, it's also the same positive value. It's also 1/2. Let's have a look at 30 degrees this direction. We'll add 30 degrees to 180, gives us 210. I'll just write that in there. So sine 210, well, sine is not positive in this quadrant. Sine is negative in this quadrant, which means it's still the value of 1/2 due to the symmetry properties. However, it's negative 1/2 because sine's negative in this quadrant. And similarly, looking over here, 30 degrees there, 360 subtract 30 degrees is 330 degrees. Sine of 330 degrees is obviously going to take the value of 1/2, but is it negative or positive? Sine is negative in this quadrant, so therefore sine 330 is negative 1/2. Hopefully that explains to you a little bit about the symmetry properties of the unit circle. Let's have a look at if we know a particular value. Let's suppose we're trying to work out the angle and we've been given some information. And we want to work out, well, what's the value of sine theta plus pi? Okay, theta plus pi must be, in this pi is here, if I'm degrading, I'm obviously moving into radians here, so remember pi and 180, they're equivalent. So if I want to know, well, what's the value of sine theta plus pi, well, theta plus pi is in this quadrant here, sine is negative in this quadrant here, so therefore if sine theta is 0.93, then sine of theta plus pi must be minus 0.93 because of where it lies in this particular quadrant. Let's look at another quadrant. Let's suppose we wanted to look at the value of sine 2 pi minus theta. Well, find 2 pi on the unit circle. 2 pi is 1 revolution. 2 pi minus theta is sitting in this quadrant. The value of sine is negative in this quadrant, so therefore the value is minus 0.93. Hopefully that gives you a little bit of an insight about the symmetry properties of the unit circle.